Good morning, everybody. I'm Nicholas Davis from Isikungu Environmental Services. Unfortunately, Roland Schulze couldn't be here today. What I'll be speaking to you about today is macadamia growing regions, where they currently are, where they potentially should be into the future as a result of projected changes in climate. So effectively, it's a climate-based assessment that we're going to be looking at for this presentation. Right. Now, the main objective of the research is to enable South African macadamia industry as well as various growers to make informed scientific decisions as to where to establish new orchards, where not to establish orchards, as well as under present climatic conditions and projected future climatic conditions, as well as to improve future practices as well as present practices in regard to climate. Now, the approach that we will be using is a natural capital approach, which we use detailed spatial, temporal, and locational databases to identify impacts of current and projected future climatic conditions. So now if you look at the image here, the approach that we'll be using is, these are the spatial regions, and South Africa has been divided up into 5,838 climatic homogeneous quinary catchment regions. And you can see on this map here that it's quite dense in the eastern regions and then a bit more sparse in the western regions. And this is due to the altitudinal breaks that were used to develop these homogeneous regions. For each of these quinary catchments, there's a 50-year record of daily rainfall, maximum temperature, maximum relative humidity, solar radiation, and Penman-Monteith calculated evaporation. In addition to this, more recently, global climate models have been used to simulate present climate as well as future projected climates for each of these homogeneous regions, as well as soils information and land cover information is also available. Further, a hydrological model called the ACRU model has been used to simulate daily stream flows as well as various other statistics from each of these interlinked quinary catchments. And you can see here that there are 3 quinary catchments per each quaternary catchment, namely the upper, middle, and lower quinary. And these flow into each other. Now, as far as climate goes, the main driver of climate change is the emissions of greenhouse gases. A major one is carbon dioxide, but there are others. And every activity that we effectively do causes or emits some form of greenhouse gases. So transport, energy, industry, it all contributes to the climate emissions. And you can see these graphs here, that there are a number of emissions, a number of gases here, all of which have increased exponentially over the past 100 years or so. And then over the past 5 years, or 4 years actually, because it's from 2019 to 2015, you can see that the parts per million of carbon dioxide has increased from just under 400 to 410, which is quite a significant increase. And then in the year 2015, we emitted 35.7 gigatons of carbon dioxide per year. So that's 35.7 billion tons of carbon dioxide was released into the atmosphere. And this is measured at a station, the only one in Africa, on a daily basis, measures the carbon content. So now the question is what impact is this having on the global climate? And from these, and as a result of this emissions, you can see the enhanced greenhouse effect is occurring. And normally you would get shortwave radiation entering the Earth's atmosphere during the day and then being reflected back as longwave radiation during the night through the atmosphere. However, as a result of greenhouse gas emissions increases, this layer has become thicker, and the result is greater radiation is retained by the Earth's atmosphere. This causes a significant increase in temperature, atmospheric as well as oceanic. And the result of this is that weather patterns change, and this has impacts. So now, how do we actually monitor this? Now, what we can look at now is global climate models. These models account for greenhouse gas emissions, as well as atmospheric circulation and oceanic circulation. And through various calculations and simulations, 4 scenarios have been developed. The current one that we are on at the moment, you can see from the graph here, is we're on RTP 8.5 scenario, which is effectively a business as usual scenario. And unfortunately, this means that climate change could potentially be fairly severe in some parts of the world. Now, multiple GCMs, as you can see from this next graph, were used to develop each of these scenarios. A number of GCM simulations were run, and then the average was obtained. Thus, 4 scenarios were developed using this information. So now, how does this apply to macadamias? We'll be using a 2-phased approach, looking at static elements, so the pedosphere and pterosphere, or soils and landscape, which is unlikely to change as a result of climate change, and then the more dynamic elements. So atmosphere, which is climate, the phytosphere, which is crop, and then a hydrosphere, which is water availability. And we'll be looking at how these impact on macadamias. So from a soil perspective, we'll be looking at soils which are too sandy or too clay for optimal macadamia growth. And from the pterosphere, we'll be looking at the slope gradient as well as potentially slope aspect. So how to plant your macadamias in relation to solar radiation. As you can see from the 2 maps here, you can see on the top soils, on the top left, the western areas of macadamias, the western areas are slightly too sandy, while in the more eastern areas, there's more clay content. And then the same with the subsoils, with a slightly different pattern. With regard to slope, the western interior, the slope is more suitable, while in the eastern areas, it's less suitable because of the steepness of the areas. But you can see in the zoomed in map that's a fairly high resolution at 30 meter DEM, that the slope is not too significant in some areas, but in other areas it is suitable for the growth of macadamias. Okay, now we're going to look at the more dynamic elements. With regards to atmosphere, we're dealing mainly with solar radiation, temperature, and rainfall. Solar radiation, we still have some work to do on, so we're focusing more on temperature and rainfall. Okay. From the 2 maps, you can see frost damage in macadamias. So on the left, you can see severe frost damage, so the number of days that are below 0, while the map on the bottom right shows more mild frost damage, which is the number of days between 3 degrees and 0 degrees. And you can see that there's less days occurring in the interior, with potentially more days occurring along the coastline, which means that it's mild along the coastal regions, and so potentially more ideal for macadamias. Now, conversely, are the high temperatures. You can see, as we know, is that the western areas are generally a lot hotter than in the eastern regions, which is not optimal for macadamia growth. Finally, we will also be looking, well, not finally, but we will be looking at rainfall as well, as some areas have dryland macadamia cropping, and one of the requirements is rainfall of 1,000 mils or more per year. And this means that there are a few areas in South Africa, mainly along the eastern coast, which can accommodate this. However, this may change with climate and could result in a decrease in the rainfall in these areas, or change in the temporal patterns. We're still busy looking at that through the various global climate models. And then another one to look at with regards to temperature is heat units and the different phenological stages. So on the top left, you can see there are 600 to 1,000 HUs between October and December. And the pink areas are the optimal areas. And then in the bottom right-hand map, you can see 1,000 to 1,350 HIUs are required for oil accumulation phase between January and March. And you can see there are fewer areas that are optimal for the growth of macadamias. Now, with regard to the phytosphere, phenologically, these plants have significant constraints climatically with regards to temperature and rainfall requirements, as well as pests and diseases, which I'll describe a bit later. With regards to the hydrosphere, we'll be looking more at the irrigation, as the majority of macadamia crops are under irrigation, so we need to know how much irrigation is required, what are the potential impacts of climate change, and how this will affect the growth of macadamia crops. Okay, so the reason why this is important is that you can see that under irrigation on the two graphs, macadamias produce significantly more per hectare than dryland cropping. So as you can see there, under the historical climate, the eastern area, which is a dry area, requires greater irrigation, while the western area, other way around. The western area requires greater irrigation, while the eastern area requires less due to a higher rainfall. However, into the future, it is projected that this irrigation requirement will change by in some areas by a significant amount, in other areas by less. So now what do we need from you? Is basically we need your inputs with regards to your observations, anecdotal evidence, so that we can improve the algorithms that we are busy developing to look at how macadamias will be affected by climate change. We also need to recognize the fact that we need to become more climatically flexible. So we need to look at areas that may become suboptimal in the future, even though they're optimal now, and areas that may be suboptimal now, but may become optimal in the future. And this is driven by dynamic drivers such as climate, etc., as well as the dates, etc., for planting for macadamias and harvesting. We also still need to look at addressing the more complex issues, such as the flower initiation, which requires a certain number of hours at a certain temperature threshold. And what we also need to be looking at is how pests and diseases are going to be influenced by climate change. One of the examples that we have is that codling moth, the number of life cycles, as you can see from this graph and maps, increases as temperature increases. So, and the increase is fairly significant from about 3.9 to 5 in a projected future climate where temperature is 2 degrees hotter. And then additionally, some help that we further need is the databases. There are two databases that are available to us. The WARMS database from DWS, which has lots of information regarding irrigation, crop type, at least water source, and coordinates, but a lot of that data is erroneous. As you can see on the map, a lot of the macadamias, according to WARMS, are grown in the Western Cape, which we know not to be false. And then as regards to SAMIC database, there's a lot of information available, but there's also some further information that we could obtain, which would be fantastic. So if you could help us on that side, please contact us on either Roland Schultz's address or my address, or these cell phone numbers. Thank you very much.